Hey thinkers, welcome to this week's episode of the Thinking Podcast. I'm really excited to have Professor Dominic D'Agostino with us this week. And for keto biohackers out there, this is a name that you've heard before. He's probably one of the most prolific modern researchers in the field of ketones, ketogenic diets. So let's, I think this is a great opportunity to really just dive into what's at the cutting edge here. A little bit about his CV. He's a professor at the University of South Florida in the Molecular Pharmacology and Physiology Department. And as I said before, really at the bleeding edge of looking at ketones, not just for therapy, but also for potential human enhancement. So happy to have you on with us, Dom.
Yeah, great to be here. Thanks for having me, Geoff. I appreciate it.
Yeah, cheers. Before we dive too deep into the biology here, I'd love to get a sense of, how you got into the space of ketones. For us, for me personally, especially in Silicon Valley with biohackers, a lot of people are looking to optimize for cognitive performance. When people hear about ketogenic diets or ketones, I think most people think about weight loss. And I think obviously there's some interesting indications for keto in that aspect. But I think in this day and age, there's a lot of people looking for enhancement. So we got into intermittent fasting. A big driver for intermittent fasting is accelerating neurogenesis, some of the downstream effects of autophagy, all those things. And one of the key drivers of some of these benefits was elevated levels of ketones. So that's how we got, our community is interested in ketosis. Curious to hear your personal journey, how, you dove into the world of ketones, exogenous ketones, ketogenic diets.
Yeah, well, I studied neuroscience as a PhD, and I was very interested in how the brain responds to low levels of oxygen. So the general response to hypoxia is a decrease in brain energy metabolism and output, excluding a few cardiorespiratory regions that are associated with the neural control of autonomic regulation, like the ventrolateral medulla, the pre-Botzinger region. These regions are actually hypoxia sensitive, and they actually are excited under periods of low oxygen and even in the absence of substrate flow. So I became really interested in the metabolism of neurons and in regards to substrate and level of oxygen. So a lot of my interest in far as metabolites really was with lactate. So for years, I kind of, was looking at lactate as a molecule that could be kind of put in supplement form. Alpha-L polylactate was something I used when I was mountain biking and was really involved in that sport. It's in the product Cytomax. And I was kind of personally sort of selfishly interested in from that perspective that I could study sort of a supplement that I was using, and this is going back 20 25 years ago when I was doing my PhD. And
typically lactate is an anaerobic substrate, right? So essentially glucose converts into or lactate is a byproduct of anaerobic fermentation to generate ATP. So it's interesting that, it makes sense, right? You don't need oxygen to produce or to utilize lactate.
Yeah, and it becomes pretty important under periods of hypoxia, especially in regards to brain energy, function and maintenance of resting membrane potential in the face of hypoxia. And that was what I studied during my PhD. And then the neural control of autonomic regulation, like how, for example, the rostral ventrolateral medulla, the pre-Botzinger region of the brainstem, kind of those neurons fire in response to low oxygen, and they augment cardiorespiratory control. And sort of, all the metabolism kind of associated with that. And ketones were on my radar, but not really something, and I think it had to do with the stigma that ketones had back in the mid-90s and late 90s. And
still today.
Yeah, they do.
Yeah, I think I'm sure
Yeah.
Yeah.
uh,
They think that it's bad because people with diabetes get what's called ketoacidosis, which is not
yeah.
good. But that's
So diabetic
that's a
ketoacidosis is, something that I'll teach on. And there's also something called alcoholic ketoacidosis, which can occur under certain conditions. And that's much different than, obviously, than nutritional ketosis. And we can get, delve into that. So I started studying, as a neuroscientist, the effect of low oxygen on the brain, and then I did my postdoctoral fellowship studying what happens under conditions of high oxygen in the brain, a high partial pressure of oxygen. So, which would mean not just breathing 100% oxygen, right? So we're breathing 0.1 or 0.2 ATA of oxygen, or oxygen like absolute. It's called atmospheres absolute oxygen. But if you're breathing 100% oxygen, you would be breathing like 1 atmosphere of oxygen absolute. But if you go to a hyperbaric environment and go undersea, for example, so every 10 meters is an atmosphere, right? So if you go down to 50 meters, you're at like 5 atmospheres, or it's like 132 feet of seawater. So at that level, if you're breathing pure oxygen at that level, that will send your brain into a seizure, a grand mal seizure, within about like 10 minutes or so. So my postdoctoral fellowship was really focused on designing technologies to understand that phenomenon. It's known as Cns Oxygen Toxicity. And to do that, we utilize various techniques in the lab that I was trained on: patch clamp electrophysiology, electrophysiological recordings of different types, different forms of microscopy like laser scanning confocal and atomic force microscopy. And during
the primary use case here was, I know, is like special forces SEAL deep sea diving, right? Like that's like basically in practical terms, where humans can face these conditions.
Yeah. So where do humans experience these conditions? And it's pretty. It's maybe like an esoteric field of study, but hyperbaric oxygen therapy is FDA approved for like 14, 15 different applications, and very common procedure for wound healing and other applications like carbon monoxide poisoning and a number of, even for cancer, for radiation necrosis, it's used. So if we know the limitation is about 2.5 to 3 atmospheres because of oxygen toxicity, so if we could mitigate that, we could potentially, hyperoxygenate someone. For example, someone with carbon monoxide poisoning, and it could be, more pressure to get the carbon monoxide off the hemoglobin molecule to oxygenate them. So you could potentially save their life. You can make the therapy easier. So that's another realm. But yeah, for what I was studying and really was funded to do, for this scenario of using a closed circuit rebreather, like the type of rebreather is called a Draeger, and it's kind of a small unit that more or less sits on your chest with special operations community. They use this type of rebreather, and it's usually used for shallow operations. But if, under certain situations, you have to go deeper to plant a mine, to evade the enemy overhead that's shooting at you, or to if the visibility is high and people are overhead in aircraft, they can see you, so you got to go down deep. And if you do that, then you have the risk of getting an oxygen toxicity seizure, or if you're down there for too long, which is kind of the case. And now with recreational diving, there's a big push. A lot of tech divers are jumping to the rebreathers, so there's kind of, people are getting more hit with oxygen toxicity. So the technologies that we developed allow us to look at like the plasma membrane and even the mitochondria under conditions that simulate this. And we used reduced preparations like dissociated cell culture systems of the hippocampus, of the cortex, hippocampal brain slice preparation, where you literally like cut the brain like a piece of bread and you stick it under the microscope that's inside the chamber, and you can do electrical recordings and fluorescent imaging of reactive oxygen species. So I developed a technique to measure superoxide anion under graded levels of oxygen and pressure. And that gave us insights to understanding that these reactive oxygen species are being produced under these extreme environments. So I started focusing on antioxidant as a mitigation strategy or a countermeasure.
Right.
And it became apparent that the oxygen-free radicals were more or less a byproduct of oxidative metabolism in the brain and the mitochondria. So kind of working my way through this, I kind of delved into, well, what if we enhance mitochondrial energetic capacity, or what if we start, putting in different types of substrates? And I was keen on actually increasing the pentose phosphate pathway to make more glutathione and things. But I stumbled upon, some of the early research on ketones and their potential enhancement for enhancing bioenergetics of cells in the working perfused heart preparation. And I bought some.
This is the Sato paper in the late 80s, right?
Yeah. Yep. And some of the work actually by Henry Brunengraber too from Case Western. He did some things with ketone esters, and I was basically absorbing all this information. And being that oxygen toxicity is essentially a grand mal, or what we call tonic-clonic seizure, I got turned on to the ketogenic diet too, and some papers that talked about the mechanisms of ketones in particular. And the first person that I actually really connected with, as far as spending time on the phone and lots of emails, would be Jung Roh. And at the time, he was at Barrow Neurological Institute, and he's really probably has one of the most in-depth understandings of ketones and redox control, and sort of was kind of skilled in the types of experiments I did, like patch clamping and electrophysiology. So I connected with him first, and he told me he thought that the ketogenic diet could ameliorate, I think was his words, Cns Oxygen Toxicity, and this was back just about 10 years ago. So I started putting, a lot of my time and effort into writing grant proposals to study this. And when we bought some ketone salts, like from Sigma, sodium beta-hydroxybutyrate, and mixed it up, in solution, started running experiments, and it was obvious that it was attenuating the oxygen-free radicals, the superoxide anion, which I was measuring, and also oxidative damage, which would be membrane lipid peroxidation, that we could measure. So,
I think that's interesting, because it seems like if you just follow nutritional trends, probably like in the last 10 years plus ago, antioxidants were all the rage. And I think, as you're referencing, you're essentially solving or resolving a symptom of potentially what could be, can you just make the mitochondria more efficient so you're not producing as much reactive oxygen species?
Yeah.
Right? So going one step below the antioxidant. I think when I just referenced the Sato paper, and I think what you keened you on this probably when you're first emerging in your research was 28% more power per unit oxygen while running on ketones versus running on glucose, which I think is some of these like interesting like baseline biological phenomenon that derives all these downstream effects. I think that So I think I can see the intellectual maze as you were carving out this path here.
Yeah, and I really saw it as an alternative fuel that had the potential to shift not just metabolism, but just the redox environment that the metabolism was sort of functioning in, because that was really, I was really focused on redox regulated ion channels and proteins and enzymes and things like that. And it was from my perspective, I was measuring oxygen-free radicals in response to graded levels of oxygen and pressure, and that was the variable I was looking at. And all I saw was that, the oxidative stress was going down, and it's still, not completely clear how the ketones are having an antioxidant effect, but it's probably doing it through a number of different mechanisms, sort of working in synergy. That's actually kind of a focus of our lab, is kind of understanding how they function as a histone deacetylase inhibitor, how they function in signaling with suppressing inflammatory pathways, even in the brain.
Yeah, which a lot of people do fasting to so fasting is one way they trigger some of these mechanisms. I think that's that's what got me personally into looking at ketones, because if you look at intermittent fasting, those things get triggered on those pathways for caloric restriction and all of that. So it's interesting, like what drives what I think is very much an active area of research.
Yeah, that's a good question. Actually, Walter Longo was a keynote speaker in the conference that we host here at USF, and gave a really good in-depth definition.
He's a USC longevity researcher. Yeah,
and Rhonda Patrick, she's an excellent resource on that, and kind of delved into that. So there's with fasting, it does kick on a genetic program that triggers autophagy, and this program's largely silenced with the way we eat now. So doing periodic intermittent fasting, or just occasionally going into ketosis, or nothing really extreme, but doing it occasionally, is beneficial in many ways. It's interesting, though, that most of the people that actually follow me, I think, or that are on this topic, as you are and your listeners are, many of them don't necessarily kind of need the ketogenic diet. It may not even be optimal, but many of the people that stand to benefit are kind of people who don't work out and don't really know of the benefits of this. In particular, what I've seen, especially from blood work, I have like some younger guys that kind of get their parents to go on this, and they're not up on the science, but they convince them that it's worth doing it. And they, they'll send me like kind of blood work before and after. This is like usually the over 50 crowd that have overt signs of metabolic disease, and the blood work is like strikingly different. The thing that really stands out is this, the CRP levels, the inflammation goes down, and the triglycerides go down tremendously, which is interesting because they're typically eating more fat, right? And then that's a good sign. It's not a good sign if someone's on a ketogenic diet and their triglycerides go up. I mean, that's an indication that their beta oxidation of fats is not optimal for some reason or another. So ketones, actually, therapeutically, ketones may actually help that.
Right. I think there's a lot of I would say confusion over fat adaptations, and is there a differentiation between keto adapted, right? Because I think in my mind, a lot of people conflate them in the same way. But the way I think about energy substrates for mitochondria, you have, the mitochondria can either use carbohydrate, glucose. You can oxidize free fatty acids, or it can oxidize, or it could metabolize ketones, right? So, in my discussions, in my thinking, one can be in this new universe where you can have exogenous ketones, essentially get ketones without having to elevate fat. Then there's like a world where there is some difference between being ketone or keto adapted versus fat adapted. What is your thinking there?
Well, you'd have to sort of define what that means. I think.
Right. I think. Yeah, because I think that I don't think there's a very clear definition. I think when people call, I guess colloquially, when people talk about being fat adapted, their metabolism shifts more towards burning fat than burning carbs.
Yeah. And I view it from the perspective as a neuroscientist, because that's, maybe I'm a little bit biased, but that's my background. But I think when we're talking about being keto adapted, I think it really has to do with transitioning your brain from, using glucose, and there becomes a period of what I call glucose withdrawal that the brain goes through. And there's a number of processes that I think happen that contribute to being keto adapted. And I think it's an upregulation of beta oxidation in the liver, of the enzymes involved in hepatic ketogenesis, and also the transport of ketones across the blood-brain barrier and also into cells through an upregulation of the monocarboxylic acid transporters. So the protein for that transporter will go up even after about 2 days of with intermittent fasting and with following the ketogenic diet. And interestingly, like if you subject rats or rodents to things like intermittent hypoxia, you can also see an upregulation of that transporter, maybe for lactate, because they use the same transporter. And then you have the ketolytic enzymes that are in the cells itself, and they will increase over time. So these are maybe there's 5 or 6 things that I mentioned there, but there's probably 10 or 20 things, and that's kind of what our lab is interested in, measuring some of these variables and how they change.
Right.
And if someone, we have many different fat oxidation enzymes in our muscles and in our liver, and some people have wide variety of activity of those enzymes. And I think there's one of the major enzymes, HMG-CoA lyase or something, there's 30 different known mutations that humans can have, and it could be on a spectrum. It's not on or off, but and I think that they may account for some of the variability that we see in people that are following ketogenic diets and, for example, not producing robust levels of ketones or just not feeling unwell when they follow the ketogenic diet. So I think these things need to be considered, and I think some of the technologies that are emerging now, you take your 23andMe data and you put that into a variety, and about a dozen or different online programs now that will tell you based on a various genetic profiles. These nutrigenomic field is growing. It's a little early to really put your faith in it now, but
that's my thinking too. Yeah, it's like the data that we do have is okay, you're fast metabolizer of caffeine, or your body produces more vitamin D endogenously or something. It's pretty basic stuff right now. I think people are making too broad claims that are stretching it. Yeah. No, I mean, I think where I was, opening a conversation was that I think normally in biology to get elevated ketones, you need to essentially be in nutritional ketosis or be basically have low glycogen reserves, right? There's never a case where you have high glucose and necessarily high ketones without high fat, unless you have a disease or something. And I think with a lot of the work with exogenous ketones or ketones that you can consume that directly enters your bloodstream as ketones and not going through, not being converted from fat, one could imagine you could be, optimized for glucose uptake and then optimized for ketone uptake, and then not be optimized for fat uptake. Where I think, typically before one would be sort of glucose optimized and then fat ketone optimized. So I think there's this seems to be a new biological state that one can now enter with the recent developments in exogenous ketones. Yeah,
the best way to adapt your body to burning fat and carbohydrates or sugar and ketones is to subject your body to that metabolic physiological state, right? So, train low carb, but also train periods of high carb. And then if you don't sustain carbohydrate restriction for a period of time and use it intermittently as a tool, sugar is a very powerful, performance enhancing substance, and it has its place in a lot of people think I'm anti-sugar or anti-carbs, which I'm not. I just think I just feel better being in a state of ketosis, but also understand that we can leverage all these different metabolites. So the things I'm interested in formulating in the lab, maybe exogenous ketones with perhaps a form of carbohydrate and creatine and lactate or alpha polylactate and other things, and then various cofactors which make those things work better. But I think it's really good to maintain metabolic flexibility to adapt your body to different eating strategies, and intermittent fasting is a great way to do that.
Yeah, it's super refreshing to hear because I think like in this, I think in this universe, people are pretty dogmatic, right? It's like uh, low carb, high fat, only way to eat, or whatever, eat a balanced diet. And I think that each metabolic substrate, whether it's carbohydrate, fat, protein, each are each have its functional purpose. Like if you don't have glycogen, you don't have glucose, you can't, like it's very hard for you to do, anaerobic sprints, anaerobic, heavy lifting, like having enough glycogen, increases like growth, like IGF-1, right? Like it's kind of like this trade-off. And I think people are very much like, hey, we're on this side of the world and there's not, like, everything else on the other side of the world is like bad for you. But just biology is, I think, just a matter of trade-offs. If you want a certain optimized use case, you would sort of optimize your training, your diet for that use case. But I think it depends on what your end goals are.
Yeah, and to use different eating strategies to your benefit and fit it into your program. Like there will be periods of that you'll just want to add surplus calories. Even if you're on like a ketogenic diet or a modified ketogenic diet, and you on one day you have 25% extra calories, like surplus calories,
right.
Even if it's not carbohydrates, that's actually going to start to top off your glycogen stores in your muscle.
Right.
Just the extra calories will do that. And periods of energy, dietary energy restriction or intermittent fasting primes many of the anabolic signaling pathways. So if kind of what I like to do is just periods where my body is not under stress, like physical or even in psychological stress, like I will kind of undereat during that time, and periods where I'm putting my body through a lot of work, I will then add surplus calories in and around that for recovery. And I think, and I was just meeting.
Yeah, what is your personal protocol? I mean, it sounds like you cycle in and out of, ketosis then, and you cycle kind of in and out of intermittent or fasting periods.
Yeah, it'll vary, that's the theme too. It'll vary depending upon what I'm doing. If I'm traveling nonstop, or I do have time to train, it may vary. But generally, I believe, kind of eat towards your activity level too.
Right.
So also I'm also testing things like constantly. So a lot of times, if I am doing intermittent fasting or what I call intermittent fasting, I will not eat throughout the period of the day and then have my first meal between 4 and 6 p.m. But during the work hours, I will be testing a new ketone, salt formula or a ketone ester formula or something. So I like to be able to test things when my body is kind of at baseline levels and sitting at my desk, whereas if I'm running around doing stuff, actually doing physical activity, my metabolites or glucose and it's going to be all over the place. So I like today, for example, I'm actually testing like the D enantiomer of different salts and different formulations of those, the D salts, and with different types of ketogenic fats. So actually after this, I'm going to run and I'm getting a whole NMR lipid profile and blood work because I'm actually testing the salts at really high levels to see if it influences like not only electrolytes but different how my lipid profile in general. So
a true biohacker. You're cut from cloth. You're running your own experiments on your own body. No, that's awesome. So it sounds like So basically, it sounds like when you're doing sort of these N=1 self experiments, you're essentially doing 1 meal type day things, and then you're sort of, I guess, you're just testing different regimes with exogenous ketones.
Yeah. Like last week, I was eating 2 meals a day, and pretty much every day, like 7 a.m., 7 p.m. And the week before that, I had a ton of teaching where I had to wake up early, sort of. So I did intermittent fasting. Kind of works better because I don't like to stomach food too early in the morning if I have to wake up. And then this week, I really wanted to focus on testing different types of formulas from, batches of different ketones that we have. And I'm really interested now. We tested a lot of things in isolation, but I think where a lot of the potential may lie, especially in, for your audience there, is the formulation of these things. I think some things kind of synergize together. And we see that certain ketone esters or salts or salt formulas work really well, for example, to attenuate anxiety behavior in different animal model systems that we're studying.
Yeah, I wanted to ask you about those two big topics, actually. I think one of the most interesting results was a recent paper you published around anxiety effects, anxiolytic effects of of exogenous ketones. I think a specific ketone ester. I think that's one area that we should dive into. And I think the second broad area that we've touched upon a little bit is, what is a universe of exogenous ketones? And we can talk about the different ketone salts, different ketone esters, and all of that. But yeah, I think a lot of us are curious around the pathways for anxiety. I think in this day and age, I think more people are overly anxious than wanting more stimulants. I think the world has a lot of uppers. I think in this day and age, we need better downers in some way. And it's interesting to see some of the results coming out of exogenous ketones is that it's potentially, very efficacious for lowering anxiety.
Yeah. We kind of study things the reverse of maybe what I'm supposed to be doing as far as, if I'm funded by the National Institutes of Health, usually it's the research needs to be very mechanistic, and you identify a potential signaling pathway and then work up, towards, animal and then human studies from that pathway. And that type of research, which has kind of been disappointing, starting from a very reduced preparation. So I like to say, in our lab, we do a lot of top-down research, and I think it'll be more fruitful when we can literally experience and tinker around with things ourselves and figure out what works from a human performance optimization point of view. When you're not pointing to this kinase or that ion channel or whatever, which I spent a long time doing, with electrophysiological studies. So with anxiety studies, we observed when we were doing our seizure experiments, where we basically we have these animal studies where we put the rat that has biosensors inside of it, where we measure brain EEG, diaphragmatic EMG, heart rate, temperature, everything, and the sensors inside the rat, and the rat is inside a plexiglass chamber that's 100% oxygen, and then that's in a bigger hyperbaric oxygen chamber, and we will pressurize that and keep it to simulate like a Navy SEAL dive until they have a seizure. And we have a video camera recording in addition to the EEG. And as soon as they have a seizure, we quickly flush with air, and then we stop the seizure, kind of like a diver would do, would surface and come up. So it's not even actually harmful, and it's reproducible. Well, when we did that with a particular ketone ester, we could extend the latency to seizure up to about 600%, which was above and beyond any anticonvulsant drug, the best being vigabatrin, which is like a glutamic acid decarboxylase activator, and it stimulates more glutamate to GABA, and it works through that mechanism.
That's an insane result, right? If you can stay under longer for 6 times longer, it sounds like, which is crazy.
Yeah, and that's, even the best anticonvulsant drugs, if you look at a bunch of them that have been tested, I'm not aware of any that approach that. Or you have to give such a high amount, you're basically sedating and putting the animal or the person into a coma.
Into a coma.
And they're less likely to have.
Yeah.
These initial studies that we did got me so interested in understanding kind of the mechanism, but it was like a top-down approach. I tinkered with cells a little bit and saw the potential of ketones, and then we had to test a bunch of different formulas to find, a ketone ester that worked. But when we did an intragastric gavage of the ketone ester and just fed it orally, essentially, the rats were really calm, and we thought maybe they were sedated, or maybe they were just a little bit drunk, because butanediol is a component of a ketone ester, whether it be a Beta-Hydroxybutyrate monoester or an acetoacetate diester. It's still combined with 1,3-butanediol, the forms that we were working with, and there's also glycerol esters that we were working with. And we thought it was because of that. But when we did another study on exercise performance and we put them on a rotarod, they ran farther, faster, and longer. So it's not like they were drunk. So my wife, actually, she works at a different facility, but she on same institute in psychology. She's a behavioral neuroscientist, and she was very interested in the behavior and was like, these rats, are definitely way more calm. I can pet them. I can, they're just much easier to handle. And she was kind of urging me, saying, we need to study the anxiety behavior in these rats because they're obviously less anxious. So to do that, there's a variety of methods, and one is the elevated plus maze, which is like pharmaceutical companies will use this when they're testing anxiety drugs or different types of pharmaceuticals. So, we invested in getting that equipment, and we ran a bunch of studies on rats, on the Sprague-Dawley rat and another called a Wagri rat. It's a different type of rat species, and we assessed different types of ketones and ketone formula. We looked at like their glucose, their Beta-Hydroxybutyrate, changes in body weight, which we saw some changes in that. But we really, the main emphasis for the anxiety studies was to look at the elevated plus maze data. And essentially what happens is if the rat is anxious, it's like a little catwalk, and it will run into a little cave to avoid sort of exploratory behavior. And if a rat is less anxious, it will come out on the elevated platform and
poke around more.
And
just more time. Okay.
Yeah, and to we quantify this, so we have cameras set up so we can assess how much time was spent in the open arm versus the closed arm and number of entries, and we can correlate that to the ketone level. So if the higher the ketones, then they go, their exploratory behavior is more and their fear response is attenuated. And so that's really what we spent a lot of time.
Was this a single shot of a ketone ester and they were just eating a normal balanced diet beforehand? Or were they sort of like fat adapted or supplemented over time?
Yeah,
Mice?
Good question. Well, we haven't done like long-term administration yet. So this was, I would call it subchronic. So it was basically giving an oral bolus 7 days per week. So 7 doses. So we come in at a predetermined time point and we give the oral dose to each rat. And essentially within 30 to 60 minutes, we put them in starvation level ketosis. And then it's elevated. We did the pharmacokinetics for it. It's elevated for about 8 to 12 hours with that dose. So we give it like a fairly whopping dose. It's definitely under, well under the LD50 of ketoacidosis, but it puts it up there to like kind of where you'd be at if you were doing like a really strict ketogenic diet. And it's harder to get rodents into ketosis than humans too. They just, for various reasons. So we did that, and for up to 1 week.
That brings like a side point. It was interesting. I think Dr. Veach has mentioned in some of his talks that humans are the only animals that are really good at ketosis, but I don't think that's true, right? Like cows go into ketosis, like different. I mean, I'm curious.
That's not true. I think maybe he just misspoke or something. But I think the other species can definitely use ketones. My wife, for example, she studies fish. She studies manta rays, the giant manta rays, and we did metabolomics on manta ray blood and brain, and show that interestingly, they dive really deep, like down to 2,000 feet, and I made her she travels all over. She was in Indonesia at one point, and I made her measure, when I was getting into this research, I was like, you have to measure the ketone levels in the manta ray. Like, she had 50 million other things to do, but the only thing I was concerned about is what I wanted to know what a deep diving manta ray's ketone levels were, because they're chock full of this MCT transporter.
Right.
And I realized the transporter was being used for lactate because it's essentially hypoxia down there. But when we measured beta-hydroxybutyrate, their levels were like 2.5 or 2.7 millimolar, which is really high. I mean, for all animal species, like mammals, would never see that high unless they were fasting or something like that. So,
Right.
and manta rays have they're like the Einsteins of like the water. Their brain is like super large compared to any other fish. They have the biggest the biggest brains of all fish. So,
Didn't know that.
yeah, beta-hydroxybutyrate production and levels tend to correlate with brain size. So, humans have one of the largest, brain per body weight ratio than other mammals, compared to a rat and compared to a mouse. So they tend to proportionally produce and utilize more ketones just because their brain's a big energetic sink. And I think we have evolved to developing that our metabolic regulation is such to preserve and sustain brain energy metabolism. So I think our production of ketones kind of reflects that it really needs to prioritize. And I think our brain is a very good utilizer of ketones. And one of the questions that I had, I was actually really skeptical of Dr. Veach's work when I got into this, because I was reading, a lot of the ketogenic diet literature, and it was talked about keto adaptation. Like your brain had to be first adapted and living in a state of ketosis before it can even use ketones. But we realized that, that's not the case. I remember talking to him on the phone. It was like, no, your brain can, transport ketones. And then I got into the literature. It was right. And then when we did the experiments with acute administration with seizures, I mean, it was very obvious because our rats were eating a high carbohydrate rat chow. And we, 30 minutes prior to diving them and to induce a seizure, that we had tremendous neuroprotection above and beyond any anticonvulsant drugs. So they're definitely apparent that it's getting into the brain. And then we did brain metabolomics and everything and saw that it was elevated in the brain tissue.
Yeah, no, I think that's a super fascinating area of research. You mentioned just like neuroprotectiveness across beyond just anti-anxiety. I think there's interesting data coming out of ketogenic diets being protective for traumatic brain injury, concussion, etc. It just sounds like, ketones are good for the brain in a lot of different ways beyond just anti-anxiety. I think there's just, there's just like a bunch of interesting use cases. That was part 1 of this week's episode of the Thinking Podcast. Stay tuned for part 2 next time.